So chapter 10 is about re-expressing data, such as in this scatter plot. Although it looks like it's pretty straight, the residual plot shows a definite curve, which means that you can't use a linear function for this. And so you re-express the data to make this straighter. That way you can use a linear regression line. So goals of re-expressing the data, you can actually use it for a bunch of different things. You can make the distribution of a variable more symmetric. You can make the spread of groups more alike. That way it's easier to compare them. You can make a scatter plot more linear, like over here. And you can make a scatter plot more spread out rather than fan-shaped. As you can see here, it's pretty spread out, and then here you have very concentrated points here at the bottom left, and then at the right up here, they're very spread out. To do this, you can change the data in a number of ways. This is called using the ladder of powers. So you have 2, 1, 1/2, what we call the 0 power, the negative 1/2, and then the negative 1 power. For the second, you square it, so you take your y value and square it. The 1 power is just your raw data, you don't change anything. For 1/2, you take the square root of it. For 0, which is our logarithmic values, I'll get into those later. For the negative 1/2, it's the reciprocal square root, so you have negative 1 over the square root of y. And the negative 1 is the reciprocal, so it's negative 1 over y. For the logarithmic values, you have the exponential, the logarithmic, and then the power. And so for exponential, you take the logarithm. You can use base 10 for this for easy calculations. You take the logarithm of the y value. For the logarithmic function, you take the logarithm of the x value but leave y alone. And for the power function, you take the logarithm of both values to re-express the data.